Hey, okay.
All right, Zoom was unhappy this morning. Took a long time for it to do its thing. Then it gave me a message saying it's not responding. Oops, that's not good. All right. Okay. Got some people here. All right. Good morning. I'm going to start. My name is Harry Ricker. This is the Cosmology discussion group for October 5th, 2025. Everybody's welcome here. I'm going to talk about um, there's problems with modern physics and cosmology, what's going on there, and why um, people in the physics community ought to consider um, thinking outside the box that they're trapped in now, which is general relativity. We had a discussion yesterday in the CMPS chat, and lots of problems in special relativity. General relativity is just as full of problems. So I'm going to focus a bit on general relativity. Okay, so then we'll talk a bit about Vadimir's proposed solution to this problem. Okay, are we good to go? Everybody see the presentation?
Yep.
Okay, so and oh, I didn't realize this was going to happen. So I'm in slideshow and I can't read I got to do something here with the bar that's at the top. So I'm going to move it to the bottom. Modern physics lacks the metaphysical coherence of Newtonian classical physics. So that's kind of what I'm thinking here. What we have is we have a problem now with modern physics has kind of gotten disrupted between general relativity and quantum mechanics, and it's kind of become fractured, and it doesn't really have any coherence anymore. That's my thesis. And it's sustained mainly by uncritical acceptance of dogma and a confusing empiricism. Well, that's kind of a lot of what does that really mean? Well, we know about the dogma in general relativity and special relativity. That all seems to be very dogmatic. You know, well, they claim everything's demonstrated by experiments. Then, when you ask what experiments and you look at it really closely, it turns out, well, it's not really as clearly well defined experimentally. All the experiments don't really seem to really demonstrate special relativity and general relativity. We've talked about special relativity and the confusion and the ambiguity and the fact that experiments don't really all seem to agree. Then we have this recent development about local realism experiments that have come from quantum mechanics. And special relativity and general relativity is based on the light constancy postulate. And it turns out that in quantum mechanics, they claim that effects can travel faster than the speed of light. And so there was a Nobel Prize in 2022 awarded to physicists who produced proof that Einstein was wrong and local realism is falsified. Local realism, it's not really clear to me exactly what they mean by that terminology, but as I explained it, it means basically the idea that the speed of light is a constant and effects can't travel faster than the speed of light. But in these quantum mechanics experiments, they show apparently that effects do travel faster than the speed of light. And that's a kind of a big oops. And So in other words, the space-time metaphysics of GR has been disproved. And these guys supposedly got a Nobel Prize for this in 2022. All right. And what's going on here? All right. So now we also have James Webb Space Telescopes bringing into question a lot of the theories of cosmology. And we've talked a lot about this before. The existing lambda CDM model doesn't really seem to fit any of the observations that are being made by the um, James Webb Space Telescope. And so they're flailing around trying to find ad hoc fixes, as Roger talks about all the time. You know,
Well, with a redshift of 32, that brings it into the dark period, and that's a big
I
no-no.
don't know that they. So do you know? I haven't seen they measured anything with a redshift of 32, but it's getting up into the
Yeah,
20.
they have
Right.
detected a redshift of 32 now.
Well, that's okay.
That
Good.
that brings it into the dark period of the Big Bang, where there was nothing. It was just energy.
Right. So they got a problem. Okay. I want to talk a little bit about dialectical materialism. I talked about this a guy that proposed a cosmology based on dialectical materialism, which is basically communism. That comes from Karl Marx. But this is really a philosophical concept that comes from Hegel in 19th century philosophy. And the idea is that thesis and antithesis leads to a synthesis. And so what this means is that if you have two conflicting ideas, okay, that the conflict between the ideas is negated. Okay, you negate and then you create a synthesis, which kind of is a combination or a synthesis of the two ideas that are in conflict. So you have this negation, both foundational. So in modern science, we have general relativity and we have quantum mechanics, and they're not fitting together. They don't go together. They've been working on trying to fit them together for 50 years and failing. So the option is, according to the dialectical materialism, to try to find a synthesis of the two. Well, they've been doing that for 50 years. They haven't been able to find a synthesis. So that suggests an alternative approach would be the theories that you're trying to combine are wrong. Either general relativity or quantum mechanics. So I'm proposing that general relativity is wrong. And that's the reason that they can't combine general relativity and quantum mechanics. General relativity is wrong. Okay, so they've been working on this for 50 years, no success. All right, here's a kind of their 9 claims of general relativity, the experimental basis. Now, I'm not going to talk about this whole binary pulsar decay. I don't know that much about that, but I do know as far as Mercury's perihelion, that's kind of controversial. People have basically said that's not really right. So that's been disputed. Light bending, I know Ed Dowdy has claimed that the Eddington's measurements are wrong, and Dowdy worked for NASA for many years, and anybody who's been involved in the CNPS knows about his arguments against the light bending hypothesis. Then there's the gravitational redshift. I know I've been involved in many arguments about this. People really aren't particularly convinced about the gravitational redshift argument. And then gravitational time dilation. Now that seems to be fairly well established, but if you go to special relativity, it's out that special relativity, the time dilation in special relativity isn't really according to the claims of special relativity. And so that I'm not really convinced of that. Then gravitational waves, people say, well, LIGO really didn't really discover what they claimed it discovered, so that may be wrong. frame dragging, that supposedly is verified by some satellites. I don't know that much about that. So maybe that's something we can accept. Superior time delay, I don't really know that much about that, but I think that's kind of been disputed. There's all these disputes about the time delays that were measured by the Pioneer and that sort of thing. Then you get black holes. Black holes, a lot of people don't believe in black holes. So is any of this evidence really valid? And and yeah, the mainstream can claim, yeah, we believe in all these things and all the claims, but you see a lot of people are not convinced. So there's lots of people out there that are not convinced. Should we just believe mainstream, even though we can see there's a lot of counter arguments that have been advanced that do look credible? I'm not convinced that general relativity is a correct theory. Okay, search for new cosmological paradigms. Okay, so one argument is that the current scientific paradigms are intellectually exhausted, which means kind of after 50 years, maybe we should have a solution to these issue of how we're going to make general relativity work with special relativity. Then we have all these problems with the cosmological models, the lambda CDM model. We've got these ad hoc modifications. We've got dark matter, that's a ad hoc modification. Dark energy, another ad hoc modification. So, they added all these things to it, and they don't really seem to be working given current evidence. So the reason is that all these standard models, they don't really, they have holes in them. They require these what they call fine tuning or tuning, which means you have to adjust the parameters to make them work. And then the question comes, what justifies these parameters that you're using to make these models work? So that takes you down to another level of argumentation about how do you justify these models. So we have this problem that the physics looks good if you look at it like the standard model of particle physics. That looks really great by itself, but when you try to combine it into cosmology and you try to combine it to other areas of physics, they don't really fit together. So there's kind of a problem here. And this argument, or what might be proposed, is maybe we should go back to classical physics, which is more coherent. While mathematical beauty seems to exist, the three paradigms involve logically separated foundational assumptions that lack the coherence of classical physics. So maybe classical physics should be the basis of our way forward, rather than trying to fit all these disjoint physical ideas together. Okay, and now I'm going to talk about the local realism issue. And I can't really say I know a lot about this. It's a problem that really is out there that needs some kind of resolution of some kind. So local realism is the universe is not locally real. This empirical result strikes at the heart of the ontology of general relativity, proving Einstein wrong. Okay, so this is a view that some people are saying, oh, hey, this is a big problem that needs to be addressed, whereas it's not fitting together. This is Nobel Prize in Physics 2022. Okay, and this involves what they call the spooky action at a distance. A big, long argument about this. Robert French has talked about this. He gave us a presentation on this a month or so ago. I can't say I understand all the aspects of it. I'm not going to speak to that. It's just that it's out there. It's a problem. Yeah. So we got a problem here. How are we going to solve it? All right. Disagreement. Then, obviously, one solution is quantum mechanics is wrong. So Roger Penrose is out there saying quantum mechanics is wrong. Well, that makes a lot of sense because obviously his expertise is in general relativity, and cosmology, modern cosmology is generally based. Pretty much foundation of general relativity cosmology is general relativity. So if you got people out there saying Nobel Prize in physics disproved general relativity, that's a problem. So quantum mechanics is wrong, right? That's an argument you could make. Okay, so we got a disagreement. And then quantum mechanics has this problem of, the Schrodinger cat issue. What is it? Well, reality doesn't exist until you make a measurement. That's kind of strikes a lot of people as a problem. So that's kind of a problem, philosophical problem with quantum mechanics. It's really been bothering people for a long time. I know books have been written about this. You kind of faced with this question about what are we really talking about? Have we gotten in physics has gotten to the point where it's no longer about explaining the world as it exists. It's become highly mathematical. And then when they run into problems, they have we move the goalpost, and then we bring in these philosophical arguments about what is a measurement, what does it mean to make a measurement, collapse of the wave function, blah blah. That's pretty arcane. So that's one way we can avoid the claim, the disproof of general relativity by the local realism argument. We can just say quantum mechanics is wrong. All right. My view is that as special relativity, because it produces paradoxes, it's obviously got to be wrong. And the problem is that you've got different realities. So quantum special relativity sort of forces you to the philosophical problem that different observers have different realities, if you want to accept that it's true. So that's a real problem. How can you have different realities? The world, there isn't one reality, there's different realities. Well, quantum mechanics kind of has the same problem. Like what is reality? What does it mean to make a measurement? None of these things are really clear at all, as far as I could see. So I'm not really convinced that either the relativity principles, the underlying principles of relativity, which in my mind lead to a very unclear definition of what the real world is like. What is the world really like? Okay, special relativity doesn't lead you into a clear understanding of what is meant by the theory. Its predictions are kind of, if it's predicting that there are different realities, reality isn't unique. That seems to me to be unacceptable. And it looks to me like quantum mechanics is sort of saying the same thing. What is real is what a measurement measures. Seems to be what quantum mechanics says, which I don't really understand. It's sort of unclear. Okay. So as far as I'm concerned, pox on both of your houses. Okay. I talked about this. Measurement in physics is problematic. What does it really mean? Okay, so they've established a theory, that's based on what an observer measures. And if you go to special relativity, what an observer measures, you get different realities for different observers. And quantum mechanics sort of has reality doesn't exist until a measurement is made. That seems kind of strange. Can't really make much sense out of that. And then, of course, in quantum mechanics, you have that there's no real determinism, which is another problem, a philosophical issue. And so it looks to me like this whole instrumentalism, they call this thinking, this way of thinking about physics, instrumentalism and operationalism, which supposedly Einstein has based his theory on this philosophy. And I'm not really convinced that this is really a good philosophy to really base modern science on. So I'm unhappy with that, and I think there's a good reason why we need to go back to really sound principles of philosophy. Okay, Minkowski space-time. Now, so here, Minkowski space-time it's basically a mathematics. It's, well, there's not anything real in space-time. It's not a real thing. It's just a bunch of events that are coordinated by mathematical equations. So it seems like space-time. Now, remember now, Minkowski space-time is really basically the foundation of general relativity. And it seems to me that it leads to incoherence of what you're talking about, because it's just equations and mathematics. And what is, so reality isn't really real anymore. It's just equations. And I talked about this. Reality is observer dependent. And then there's this problem that I don't really understand how general relativity and special relativity work together, because you don't really have paradoxes in general relativity like you have in special relativity. So what does that mean? I don't have any understanding of what that means. So general relativity seems to not really be, it looks like it has a faulty foundation in special relativity, but then it seems like they make a lot of the paradoxes go away in general relativity, but general relativity is kind of like, it's just mathematical equations that say things like space and time are curved, whatever. What does that mean? I have no idea what that means. So from my point of view, we need some kind of physics that's really physics. This is, to me, this isn't really physics. This is just mathematics, talking about philosophical principles and trying to find experiments that justify your philosophical mathematical viewpoint. And then when an experiment doesn't agree, you basically find some way to say, well, that the experiment doesn't really matter. Okay. Is space-time the correct substrate of emergent reality? Okay, that's a lot of meaningless words, but really, I'm not convinced that space-time is a meaningful physical concept. It doesn't really seem meaningful to me. What I talked about this, what does space, curved time and space mean? I do want to bring out one point here, which is nobody's ever shown length contraction, an experiment that proves length contraction. I don't understand how we can believe a theory that one of the crucial aspects of the theory has never been demonstrated in any experiment. Show me that space is contracted in any way, shape, or form. I don't know of any experiment that's done that. I don't think there is. So how can you base a theory when yeah, it looks like time dilation or there's changes in the way clocks measure time is affected by gravity and also appears to be affected by motion, but show me that space contracts. No, nothing. Nothing convincing there. So anyway, okay, so we have this other aspect that space-time doesn't marry with QM consistently. So I don't know what that means. It just, I talked a lot about that before. I'm just repeating this point here again. Numerous attempts to create a quantum theory of gravity have failed, most famously string theory. I think they've given up on string theory. Maybe some people haven't. Then there's quantum loop gravity. I have no, that seems to be, so they've sort of run out of ideas. All right. want to move ahead here. Okay. Particle physics, quantum field theory, quantum field theory. Now, quantum field theory seems to be kind of obscure as to what quantum field theory even is. I can't really understand it. And it looks like they're saying that there really aren't particles. There really are particles are really fields. And now you're into the wave particle duality thing. It seems to me this is a real problem in physics. I mean, what is it that we're talking about? Make up your mind. Are we talking about fields? Are we talking about particles? What are we talking about? Don't really know. It's supposed to be the most highly verified theory of all physics, conforms to all the empirical tests. To me, it's just a lot of mathematical idealism. And basically what you have are all these symmetry groups. Okay, you got symmetry groups combined with symmetry groups. You got SU. I don't want to go into it. It doesn't really, to me, it's just not physics. It's just mathematics that they've kind of imposed on the physical world. So they've imposed mathematics on the physical world and say, oh yeah, we did these experiments that prove our theory. But what's your theory? Your theory is, I can't understand it. So it's so obscure, only fancy dancy mathematicians can really understand it. Does seem to have some problems. The main problem is this renormalization issue. The renormalization, which seems to be the main mathematical um, technique, if you will, that's only really, as far as I can tell, only these people who are trained in how to use this technique actually understand what it does. So, to me, it's just kind of mathematical mysticism. So physics now is reduced to mathematical mysticism of the renormalization issue. Okay, and of course, then there's this coupling constants. Where do the coupling constants come from? Theory doesn't explain that. This kind of also goes to the fine-tuning issue, which is the parameters that make the theory work don't seem to have any justification. They're picked out, they're empirically decided by the experiment. So what is a theory? Is a theory really explaining physics if you have to pull parameters to make your theory work out of the air, so to speak? Okay. And then, of course, to make QFT work, we've got special relativity, which, wait a minute, well, now we got special relativity and we got quantum mechanics. So we got quantum mechanics and special relativity supposedly combined together to make this theory work. Well, we know special relativity has got big problems. We know quantum mechanics has got big problems. So now we got this theory that's a combination of two theories that don't seem to make sense. So how combining two controversial theories claim to be, I don't understand how this works. To me, this seems like trust us, we're right sort of physics. We're right because we're experts and you're not. We can't, you have to spend 10 years and read and get a PhD in physics to understand what we're talking about. To me, as an observer, outside observer, electrical engineer, this doesn't really convince me of anything, so I'm skeptical of it. Of course, QFT doesn't include gravity, so there's a problem there. It doesn't really explain. So this is another example where the theory's got holes in it. Okay, and I think this is a repeat of gravity's not a force. The particle physics is based on these ideas that these forces exist. They're not really forces, apparently. They're fields. Yeah, but then they say that there are particles that exist. There's gravitons and photons. So these fields aren't fields. They're really particles. Don't really understand what any of that means. Okay. Particle physics doesn't predict dark matter or energy. Okay, so we've got this fundamental theory Doesn't they've done all these experiments to try to find dark matter, the dark matter particle. They've never found the dark matter particle. So dark matter, and you can't really get dark energy out of particle physics. That's another problem with what they're doing. And so, this is another problem of, you've got this fundamental theory that's supposed to be underlying cosmology, but how do you get dark matter and energy out of the fundamental theory that underlies cosmology? Well, apparently you can't. All right. Then I want to basically going to kind of wind up here with there are people who claim that the mathematical basis of general relativity is false. Stephen Crothers, he's been involved in the dissident community for many years, and he talks about the unimodular defect. And if you're interested in that, he's got a video on YouTube and papers published. And then, of course, I basically pointed out that special relativity is kind of screwed up and it's mathematically wrong. So I'm going to put my own theory here. This gentleman, Vedat Batu, has written a very long book. He contacted me a number of years ago. I don't know if he's still alive or not, but he's got, this is, I believe, published on ResearchGate. It's a very large book that he basically analyzes special relativity and goes into general relativity and claims general relativity is wrong. So, there are people who basically looked at the entire basis of both general and special relativity and basically claim that its mathematical underpinnings are wrong. So why are we promoting or believing in scientific paradigms that really basically seem to have a lot of problems? Okay. Essentially, it looks like that the mainstream is sort of stuck in their general relativity paradigm. The experimental basis of it isn't really quite as strong as they would claim it is. I noticed that they claim that special relativity has been proved to all these high orders of magnitude, and I don't really find any of that particularly convincing. In general relativity, I'm not really convinced that general relativity is correct. It seems to me that these theories are really basically not really that well established on in factual and experimental evidence. Of course, now in the case of general relativity, you have the problem with the local realism argument, which that comes out of quantum mechanics. I'm not really convinced this really convincing argument. Of course, they can't get it to work with quantum mechanics, so there's no unification in physics. That's been 50 years they're working on that. That doesn't really seem to be working out. So you would think at some point that they would have come to the conclusion that maybe general relativity is not a good theory. But I've watched a lot of videos where this discussion has been going on, and it doesn't seem that there's so much dogma that they really don't consider that general relativity and special relativity are false. They're like sacred cows. And at some point, you'd think they'd go, hey, maybe we should think about this some more, but no, they're not doing that. Now, remember, I'm not really criticizing quantum mechanics because I don't know that much about quantum mechanics to say that much about it. So I'm basically arguing that, the real problem here is in special relativity and general relativity. And I'm thinking that I'm more convinced now that we need to go back to the beginning point, which I think is what Vandermeer is arguing. And by going back to the beginning point, maybe we can figure out some of these problems rather than assuming special relativity and general relativity are correct and then immediately that leads to we can't really unify physics anymore. So it looks to me like we got a lot of problems in physics, and at the beginning, 100 years ago, you probably would have been saying, oh, okay, this is great. We've got quantum mechanics, we've got general relativity. This all looks really great. That was 100 years ago. These theories have been around for 100 years. And after 100 years, we've got all these problems. And they've been working on solving them. It's not like they've not been working on them. So I just think perhaps maybe we ought to go back to the beginning, start over again. And Vladimir has proposed that we do that by a return to classical physics, as I understand it. Maybe that's the way we should go. I noticed that I can't pronounce that guy's name, Butalev or what, Halim. He had a good presentation where he argued that the Compton effect could be explained by classical electromagnetic theory. I think that's interesting. Maybe they should be looking at that more critically rather than just assuming that all of quantum mechanics and its foundations are correct. Okay, that's kind of my presentation. I don't think we're going to have much more time here. And I would expect it. I'm going to get cut off pretty quickly. Oops. Well, it looks like we got maybe 3 or 4 minutes. Okay. Any questions here before we get cut off? I'm trying to.
I have a lot of questions or comments. New guy here, Ido. Rick introduces me. Is Rick there?
Yes, go ahead.
Rick, can you please introduce me? I mean, this is your thing there, right? Please help me out here. I'm new.
Well, yeah, guys, this is Ido Cal, the inventor of the structured atomic model. And I invited him here to talk about the atomic model at some point. So there you go.
Good to see you. First, quick comments, sir. Lovely presentation, and you're talking my language, sir.
So you are attuned to the fact there are a lot of confusion and contradictions. That's kind of the point I'm trying to get at.
I would love to pick up basically what you ended up with, going back to classical physics, I think you said, or something akin. And maybe, just maybe, I can offer here an alternative or a base for that, but we'll see.
Well, that's what we've been talking about. That's what Vladimir has been talking about. Right. And I think there's some validity that might basically the point I'm trying to make in this presentation is that there's some justification for doing that. Maybe they made some mistakes along the way, and we shouldn't be with dogmatic adherence that these foundational theories are correct.
I am so jazzed, sir, because this is providence or something. Thank you, Rick, for doing this. Because not too long ago, I finally made my own examination complete regarding shows the structure for each element specifically, and it has many consequences, if you will, for what you would call physics. So, like I said, you're talking my language. Usually I am the one speaking the language you just used in your presentation, how things are wrong or don't make sense or are illogical, or if you dive deep in, there is no real evidence. The main thing I ran into is the neutron. I consider the neutron a composite particle between a proton and an electron. Of course, people start objecting and asking questions. Well, we can all go into much detail there. But through the structure, and the structure cannot be resolved from any quantum mechanics formulation, for example. You cannot do that without putting in your own parameters and whatever. It's an ignored or an irresolvable problem, the n-body problem, for example. There is no there is no logical atomic model that is congruent or in agreement with other models. There is no atomic model, for example, that can predict logically the split up of the uranium atom. My model does all these things. And like everybody else, I'm completely ignored by the mainstream, of course. But recently, then we dove into the binding energy story, and we did all that. And this model, my model, allows you to upfront calculate. Right now, it's still more or less roughly, meaning it's more or less correct, but it's not precise. And precise is due to other problems that we can go into. But we went into that, and then I found out that within the standard model, within what they call quantum mechanics, there are simply huge mistakes. And the mistake that I'm alluding to is the mistake of the mass of the neutron. There's a whole story here. And the story is that I can show, and that's what I'm working on currently, I can show you conclusively, without problem, but we're working on writing down the whole story, that the mass of the neutron is a wrong interpretation. So here's the thing, the neutron within the nucleus, within the standard model terminology, not my model terminology, is that the neutron within the nucleus is the same as a free neutron. And that is a problem. They want that neutron to be the same. They want that neutron to be a fundamental particle, which is not possible for other reasons. So they could do their quantum mechanics. And the quantum mechanics required, according to Bohr's interpretation, something moving within an atom, the electron at first, and maybe other things. And that motion component never went away. So the atomic models became a irrational, unknowable, and you did your presentation there with many, many good things. I wrote them down. You know, it's all unknowable, and you can't know it before it's measured. You can't know its position or speed, all these things. And they come up, then antimatter comes up. And so the nucleus of an atom is a complete mysterious thing within the standard model. And then you go like, yeah, but I have a different picture. And they go like, well, everything is already known. Everything is explained. It's all there, no problem, except it's not. And the mass of the neutron for the free neutron is simply different than the neutron within the nucleus. The neutron mass within the nucleus is actually a variable, and I can show all this conclusively. What I'm trying to say, sir, is in answer to your questions, I'm going to be very bold here, and I do apologize for my very, very arrogant introduction, and I mean it from the best of, from the good side.
Bottom of your heart.
Yeah, thank you. English is not my first language. I do apologize. But you asked the questions a couple of times rhetorically. Why are they clinging to these models? Why are they not going back? I've asked these same questions myself so many times. And the answer that is slowly dawning on me is it's not wanted. It's not wanted for many reasons. One of the reasons I really believe, especially looking back in historical records, especially for this mass determination, for example, it simply reeks of intervention. It reeks of control. It reeks of a lot of confusion all over the world, so you can control the real good stuff. Let nobody else know what's going on within nucleus. So we can resolve basically nothing, because everything comes from there at first. So I don't know where to go from there, except that I really enjoyed your presentation. And for whatever it's worth, sir, you have my full support there in criticizing this. And I believe I have something that would shake the foundations of quantum mechanics, meaning I can show how that mass is wrong.
May I ask, Ido, are you a professional physicist? The reason I ask is most professional scientists or physicists, by definition, are not dissidents.
Yep.
So could you say maybe a word or two about your own antecedents?
A very valid question, sir. I will try to comply. My name is Ido Kaal. I'm from the Netherlands. I always have been, but I interact a lot with the English-speaking world because of these topics. My background is environmental analytical chemistry, so it's pretty close to physics. All the basic physics is there. Especially in analytical chemistry, you are introduced, for example, to spectral lines. So you learn all about that field. Yeah? So there's a strong connection to the field of physics, if you will. That is my background. Then I worked in the IT sector, and then I started to do my own thinking, which is now like 15 years ago, which led to the accidental discovery of a new atom model. I say accidental because I never set out in the morning to go like, oh, I'm going to invent a new atomic model. That was never my intent. That is how it grew, simply through research, if you will. I hope this answers your question, sir.
Yes, thank you very much.
Okay, well, I'm going to say we do have a Saturday morning um, thing that's run by Ian, and perhaps you might like to give a presentation on one of our Saturday morning sessions.
I guess I can totally do that, but I would need a little bit of preparation time there.
Well, I don't think I think Ian's got.
We're not free until the beginning of next year, but if you're ready anytime after early January, that would be fine.
Okay, no, but yeah, longer term, we can totally go. Well, that would be an honor to do something like that. Yeah, for sure.
We need you to we need you to get your email to Harry so that he can put you on the
Can you,
list.
Rick, may I lean on you to facilitate our email exchange later on?
Yeah, sure. I can if you
Okay.
can send it to me in Discord, I can
Yeah,
copy and paste it and give it to Harry.
will do, will do, will do.
Okay.
Yeah.
All right, you might want to include Ian if you on that too.
Well, I'll just give it to everybody. Like I'll just
All right, okay,
on
that's
on,
fine.
on the reply all.
And if Ido is able in the not too distant future to think about perhaps a title of a talk and maybe a line or two description, and if he popped that over to me, I can then put him down in the roster. Because if we don't do that, then it mightn't be available until springtime creeps on. But if you could let me know in the coming weeks, maybe those things, I can then fit you in a slot.
Okay, good. All right.
Will do, will do. Yeah.
All right. Well, thank you for saying kind things about my presentation. My presentation, to be honest with you, really basically, I didn't really come up with a lot of the things that were in there. I basically went around and looked at what people are talking about on YouTube and ResearchGate and some of these places, and I kind of tried to summarize what people were saying in criticism,
Right.
and I tried to capture some of that. But then I also layered on my own confusion about a lot of things that I don't really understand.
Well, it's very common, the confusion that you expressed, and anybody diving into these topics seriously, like you said, you did, usually comes to the same conclusion if they are even remotely scientifically honest, if you will. Only the zealot people that have an interest in the field for a paycheck or status or power or whatever seem to be defending these things, or the people that really, really like to think about these things because they hope one day they will get the Nobel Prize for a fictional story. And then they overwhelm you with scientific language, usually the professionals do. And they tell you, well, that's all been proven, like the neutron. No, it's been proven. I've had it with a peer review process. One time we tried our luck. We knew we were going to get into trouble. We knew, but it was the fringe group, the cold fusion group, so the ISCMNS. So we go like, okay, maybe they will accept it, just maybe. So we tried our luck, and there were some things, and then let's do a peer review. Uh-oh. And yeah, that went wrong. So the neutron was proven to be a fundamental particle, so we should no paper rejected. And I go like, well, I've looked at the requirements, and you do not reject a paper or any kind because you do not agree with a statement there. That is not a valid reason to reject the paper, because I have a defense there. That's the whole paper. No, 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 couldn't do that. So, yeah, these things are real.
I think I know I've experienced that. I do find your interesting. I've always thought that the neutron was a composite particle,
Yeah.
and that goes back to when I was a young whippersnapper that had just graduated from college, and
That's when we still think, sir. That's when we're still allowed to think. So those are dissident thoughts.
right. And my idea was that this is my little foray into, and this goes back to the 1970s. My idea was that the what was powering quasars was the disintegration of the neutron. So I believed in that quasars were like compact aggregates of neutrons, and that what would power them would be the disintegration of neutrons. And the neutron, when it disintegrated, was the source of power for quasars. That was just a naive idea I had, and what you're saying sounds interesting to me.
Okay.
Well, how
I
is
would
it
just,
how is it determined that that a neutron on its own is a different mass than with an atomic system, though?
And that is what I've done.
Okay, cool.
And but you can do it yourself if you want to. You can check these things. That's why I dare make this bold claim. If you look at, there are papers about it. If you Google it, the deuteron disintegration with a photon, something, something. And if you look at it, they chose the deuteron for the low binding energy, and way back in 1932, 33-ish, they were able to do that using a gamma ray coming off from, I don't know, some kind of isotope they could use. So they could release a gamma ray of above the 2.2 threshold. So they could disintegrate, excuse me. I have a cold there. So they could disintegrate the deuteron, and then which would split then in a hydrogen 1 and a neutron. So now you can determine the neutron as the only unknown. But if you put in the masses, and then becomes the question, the neutron within the nucleus of the deuterium, which is a proton and a neutron, right? But in combination. And you have a neutron that is free. So you calculate a neutron that is free, and and then you go back, then that should be the answer. But if you put back the answer of a heavier neutron than the proton is, and you put that back into a deuterium with a proton and a neutron, you're going to get wrong answers in principle. But there are all kinds of ways to fudge it.
Wrong in what direction?
Say again, please, sir.
Ido, wrong in what direction? A greater mass when it's in a nucleon?
Yeah.
Or smaller mass?
Right now, the neutron is more than the proton by adding an electron in 0.782 MeV.
Well, I thought you were saying, excuse me, sir, I thought you were comparing the free neutron mass with the neutron mass when it's within a nucleus. And that's what my question focused on.
So the free neutron is a fixed value, but they attributed 0.782 MeV plus the electron and the proton together, and that's the neutron mass value that is known and fixed. They apply that within the nucleus. If you do it correctly, you will find out that that missing mass from a fusion event to create the nucleus in the first place, the deuterium, that releases a gamma ray that is equivalent within the standard model to the mass, to the binding energy. And the binding energy is therefore the missing energy that was emitted. The missing mass is equivalent to the binding energy.
So you're saying that the neutron mass in a deuterium nucleus is less than that of a free neutron?
Yes, and not only that, as we know that the binding energy per nucleon varies per element, as everybody here I'm sure knows, that means, and you can do all these calculations, each time you reach a different answer for the neutron within the nucleus, and that means it's a variable. A variable per element. And I think this has consequences, especially for quantum mechanics. If you look at the free neutron decay, it decays into a proton, an electron, and 0.782 MeV, and that number is very important. That 0.782 MeV is attributed, therefore, to the neutron via the free neutron decay, right? It's reverse engineering. We can determine it. The problem is this. Every neutron is therefore in the standard model terminology, not my model. In the standard model, therefore, all the neutrons are a little bit too heavy, for starters, with 0.782 MeV. If you correct every neutron that you count in the standard model and you do any kind of mass determination in a nuclear decay step, and you reduce every neutron with 0.782 MeV, you get the correct values. That also means, this is why I'm so adamant, sir, that means that the mysterious decay steps such as tritium and carbon-14 are no longer mysterious. In fact, they are the observed photon emitting of 0.1 MeV is suddenly congruent and entirely correct with the calculated value. And right now, there's a discrepancy of about 0.78 MeV. Ah, what do you know? What I'm saying is, I can show, this is the fix for the neutron mass. This is the fix. Now all these decay steps are no longer mysterious and then they no longer violate the conservation of energy. And that is a part of the historical build-up of quantum mechanics, if I'm not mistaken, but the history records are large. So,
Ido,
yeah.
What ultimate conclusions have you drawn through this observation or this idea? Like, what does it imply or suggest about reality?
Okay. Well, I refer to the presentation of I don't know all the names here, of the presentation we just saw. I
Harry.
wholeheartedly support that view, at least. Because what I found is that much of what we right now consider accepted mainstream science and the crown of human development is in fact a farce. It's a farce. And that is a very, 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 for me personally, absolutely devastating conclusion, but it's the truth. It does not mean there's not a lot of good stuff out there, right? I'm not saying that. But the models are a farce. Not only that, we are being lied to on purpose, I believe. And that is my personal view. I could be very wrong there, mind you, but it's just my personal view. Because of all kinds of powerful people that have benefit from this. I don't know exactly why. I don't care why. I do know to fix this, you need to go back to basics, like the stuff that I'm talking about, and do some real physics again and some real things, because right now, physics is overrun with concepts that I saw 20 and 30 years ago in Hollywood productions and series and whatnot, so time travel and teleportation and all that kind of thing. Nowadays, they are considered more or less realistical things. Again, the presentation alluded to many of those. So we lost our way. There is no more real physics research out there. There's no more link to reality out there. It became a mathematical thing, and then they forget one apostrophe whereby the neutron in the nucleus becomes a free neutron, forgetting that the neutron actually absorbed that energy. They just conveniently don't talk about it. So there's no honesty in science. And my main conclusion is there's only one particle in the universe that's a proton. The interaction between the protons is done via the electron. and out comes what we call light, the whole light spectrum, and then we have fields and whatnot for the charge differences. What I also found is that an atom self-organizes and that the proton, the only one true particle, is a variable, and its mass depends on the stress level within the nucleus. It depends on the stress level / binding energy within the nucleus. So that is my conclusion. And what to make of that? I haven't gone that far.
And that's what Vladimir is pointing out is a return to classical physics.
Yeah, totally. I call it my own wording, and I've been using that for years, is we need a clean slate approach. But that is exactly what you said there. Yep.
Could I just ask a specific question for your own personal opinion on the work, say, of your fellow countryman, Hendrik Lorentz, at the end of the 19th century, say, beginning of the 20th, and maybe that developing into the special relativity theory of Einstein. So I suppose in a way I'm asking, do you think Lorentz's work was a farce, or was it traduced later by people like Einstein?
Okay, let me tone down a tad there. A farce, there's a lot of model quantum mechanics farce or string theory. That kind of level is the farce level. Many researchers are, in my mind, still great researchers, sir. So I should tone down a little bit there, right? You know, Chadwick did great work. For example, just to name one, in Germany there was Lite Meissner, who did the discovery for the radioactive material and whatnot. Those are great discoveries. You know, there's so much great work. I can totally be forgiving that somebody thinks of a theory or a model and that certain parts aren't correct or anything, you know, or leaves room for improvement. No problem. But right now, the tone, you know, in 2025 is so much different. So most people around that era, I consider original thinkers, and I have nothing but respect for that, even if they were wrong. Because you have to look at it in the time zeitgeist as well, right? They didn't know certain things back then that we know now, or think we know.
So do you think there's been a sea change? I mean, maybe in the last 50 or 40 years, you seem to be saying a smaller time, 30 years, where people are just losing the run of themselves, if you like, and abandoning traditional logical mechanisms of reasoning and so on.
It
You
seems
seem
to
to be saying
become
that,
more and more.
because you seem to indicate that there was some genuine thinking. A
Yeah.
lot of us date the problems of modern physics, which I think we all agree on actually, to around the beginning of the 20th century and around 1905. I raised the special theory of relativity of Einstein because that's one of the major stumbling blocks that I think most of us would have.
Well, I don't believe relativity is a good model, so I agree there. But that is not like I do not look at that like that's the farce. That was an attempt to describe something in that time frame. So there were many people in that time frame in the early 19th century, so 1900s and something. It's the time of Tesla. It's the time of the development of so many things. I think that was a great time. I think I would have enjoyed living in that time in the discoveries. And then from the 1930s, things became weirder. Theoretical physics introduced itself, and the theoretical physics led to the discovery of the greatest weapon of all time and the greatest energy source of all time for humanity, which changed the field. Since then, the field is locked up in we know for sure this is it, thou shalt not touch it. And the later development of the last few decades has become that science, on public at least, has become science fiction. And more scientists are delving into it. And now, in the last few years, which is another very worrisome development, we see the introduction of AI, which is probably going to be the death of it, because I see all kinds of papers already appearing, and they can be, yeah, well, produced by the boatload. And they make no sense, but it looks great.
So you would think your own views would be that these recent developments have rendered science to be even more dogmatic than it ever was, with sort of high priests who describe almost impotently, infallibly what the dogma should be, and it's unquestioned. So it's the nature of an unquestioned religion. That's what you appear to be saying. Am I correct in interpreting it that
I
way?
I I guess that is a way of wording it to compare it to a religion, and they are at least at the very least zealot-like reactions, right? You cannot even debate certain things. They actually do become quite agitated the moment if you start to dispute it. No, 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 it's this and that. And that reminds me, like a priest. No, 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 the truth is. Then that's another thing that we see right now in this day and age very much. Science is settled. Well, I always, I hate that phrase, but no, science is an inquiry to, figure out something. Science is not a collection of factual, between brackets, truths, right? If the moment we start interpreting science like that, and that is what I notice as well at the moment in the public arena, that is kind of, the public perception. Yeah. Yes.
Yes, led by the media and the politicians, and I suppose the powerful in society, they are indeed using that phrase all the time. Look, there's no point in questioning this because this is settled science.
Yeah. 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 And I hate it, but they don't listen to me, sir. So
Yes.
Nor me.
yeah. Yeah. Oh, well. So yeah, I think in short, science is hijacked. It's used for other purposes, less than crystal clear purposes, at least. And I think that's what we're running into. At least that is what I find. You know, science should be pure, should be good stuff, should be for everybody, should not be censored. But we live in a realistic world where, there are other factors going on.
Okay, any other comments? Wow, we got dead science, silence here, dead science.
Food for thought. Forgive my bold introduction here. So, yeah.
You're doing fine, Ito. You're doing fine.
Okay.
I
Yeah,
think
it was very
everybody
cool.
interested in what you have to say about the atomic model.
Okay.
I don't know what the rest of the talk is going to be about, Harry, but carry on.
Well, my point was, and I wanted to sort of lead, I was really kind of seconding what Vladimir said yesterday in the Saturday morning, where he was talking about classical physics. And I'm kind of wondering at this point, we've had a lot of talks by Vladimir, and Vladimir is sort of wondering whether people really understand what he's talking about. And so we're sort of looking for some kind of what do people think about what Vladimir's proposed cosmology? He's kind of frustrated by his last talk. He sent out his paper and asked for comments, and I was the only one apparently that offered comments. And so the question is, do people just don't understand his model, or the people that think he's right and great? And so Vladimir is looking for some feedback. And one of the real issues is where are the areas that seem to be more fruitful, in my opinion. What do you think about Vladimir's world universe cosmology? Do you have any? I mean, we don't really. Vladimir's given a lot of presentations, but he hasn't gotten a lot of feedback.
Whom are you asking, Harry? All of us?
I think he's
Yes.
asking all of us, yeah.
Yeah, okay. You see, I said, I think to Vladimir some time ago that he's a very prolific thinker. And I mean, he's written so much and he's able to home in a particular area and maybe show you how it evolves in regard to particular elements that we're looking at. But I have my own particular bias, and it's not against physics and in favor of mathematics. Quite the contrary. I think everything has to be based on physical results. However, I think mathematics is really the handmaiden, I think I used, the handmaiden of physics, and it's very important. And I said I always like to see a paper with maybe some mathematical quantification. Now, Vladimir actually, of course, reminded me that there was one paper of yours that I was quite interested in, did have that. But most of the other papers, if you forgive me, and you're probably simplifying them a bit for the general public who haven't been looking at this, you've been looking at this for 25 years, I think. But a lot of your papers are just giving results. Yes, you're to be praised, giving results and showing how your fundamental constants are coming out. But, that's it. I don't know what the basis of it really is. You have ideas about the world universe model and about the medium. And I often think that's similar to my own ideas. I use the word ether. I'm unashamedly using the word ether. But I don't know. Much of it, if you forgive me, is description. Just claiming what your theory is about, and it'll help the average person who wants to know something about your theory. But I want to delve a bit more. I want to go into equations. Now I know this one paper you had Maxwell's equations and how it related to your work and so on, and that was something I could address more easily. I find your papers very helpful to tell people what your ideas are who formerly were not aware of that, but not specific enough for me to comment on, if you'll forgive me.
Coming from a layman's perspective, Vladimir's world model seems to be very complex and complicated, and it takes a long time to put forward the ideas within the model. If there's a way that you could condense it and make it simpler to lay persons to understand, then that might be an avenue you could explore to, further your model.
I think
Now we have
do
two
that in being very
contradictory.
concise. You've written a couple of papers, 4 pages or something. That's good. But maybe if you could give a page, 1 page, say, on what Rick is asking, and then because we're contradicting each other in some ways, and then give 3 pages of what I want, more theoretical work, substantiating the 1-page summary. That might help.
Okay, anybody else? What about you, Jerry?
Well, I admire Vladimir on many levels. As far as like I'm a scientist. Well, I consider myself a scientist. I don't have a degree. However, though, I guess I'm more theoretical, and I want to question such ideas as, how the universe began, because I don't think it began, for instance, and I don't really think that there are 4 dimensions, for instance. So that's sort of some of what I think, I guess.
Right.
Well,
there are 3 dimensions, and you can add time as a special thing if you want to, and that'll be that, right?
Vladimir, could you, Ito doesn't know your model. He hasn't been exposed to it yet. If you could summarize your model for him quickly, maybe?
Guys, thank you so much for your comments about my presentation. It was about 20 of those, and all of them were different. How to summarize these 20 presentations, at least with 2-3 minutes talk? Guys, I don't know how to do it. You told Ian about my Maxwell equations. It was only 1 paper, the 2 Maxwell equations solved. How it is complicated, how it's difficult to understand even for me. How can I present this not my calculations, some theoretical guys from Holland and Ukraine about this transformation of Maxwell equations. Because let me tell you, usually we use Maxwell equations for vacuum without any sources, without any problems, and we can clearly understand them. We have vacuum, we have the speed of light and all this stuff. It's simple, but it is far away from reality. This is my main point, and it is not my point, theoretical point, very deep theoretical point about Maxwell equations. But for you, Jan, I will tell you, I have a special paper about classical physics, mathematics. I named it Mathematical Review of My Model. And all the calculations I've done with all my parameters in one paper only. Why I've done in such a way? Because unfortunately, guys don't know classical physics. And unfortunately, they don't like mathematics. I was it I was I didn't know, I was confused what to do with my presentations. Thanks to Nick, he proposed me, guys, to read my papers. He told me in each paper, you give me so much information. I cannot take it if you will talk about it. Please show your presentation, comment it, and so on and so on. And I followed his recommendation. He was absolutely right. I avoid mathematics because I don't want to overload you. Always I'm showing, even the last, my presentation was particular about fundamental constants, fundamental parameters, and so on and so on. And I showed you how I calculated very important gravitational parameter based on a very simple classical approach. I showed you only one. And then I demonstrated all the other equations because I can talk about the other equations with the same equation.
All right. You're
Know
going to
them
get cut
from your
off.
school. I'm sorry?
We got a minute.
Okay, I can continue my talk a little bit because for me it's a very important, your feedback, guys. Harry, he told me, he told absolutely right. I'm confused. I'm talking, and you don't understand it. One story. It's not enough for you mathematics. I will present to you mathematics. What you really need to understand, because it seems to me that I try you in a simplest way about my model and it turned out it's not enough. If I will go deeper with mathematics with all this stuff, maybe nobody has this qualification.
A little bit, you asked a few questions. You said it says owner. Can I inquire to your name, sir?
Oh, thank you. Yes, I'm sorry. I acquired a new machine just a couple of weeks ago, and for some reason or other, it's not giving
No
my
problem.
name. Ian Cowan.
Ian Cowan?
Yes, Cowan. I must try to update my name from owner to Ian Cowan.
Okay.
I'm not trying to be anonymous by any means.
No worries. I thought it was
I'm
good
sorry
to
to
know.
ask. You don't have a video available, do you? You don't have a camera
I
there?
do not on this computer. I came ill prepared, and I do have a laptop. So whenever next time I can provide, maybe yes.
Okay, thank you.
Harry
Ian,
and
if
Ian, I just put Ito's email in the chat in the Zoom here. So if you want to grab Ito's email, it's in there.
Ian, if you have a free Zoom account, you can start your Zoom and then click on Harry's link, and it'll come up with your name and everything right there.
Okay, Jim. I think I did something like that once and it worked, but I probably
Yeah. Okay.
Thank you.
All right. All right. So
Were you able to retrieve the email?
no.
It's in the chat down at the bottom.
I tried to get it, and oh, there it is. Okay.
Yeah, there you go. Okay. Carry on.
Is Ito short for Edwin?
There are both just names that people would use, so it's the calling name, not the official name, right? Okay.
All
Yeah,
right.
that's just his online name,
Okay.
Ido.
Well, Ido, I go through life as Ido now, and it's more to my own choosing. I guess it's part of the life. It fits better with the current phase of my life. It's a Japanese thing, if you will, from the Orient, something I picked up.
Oh,
There you
My
go.
life morphed. So my life did like the nuclei. I transmuted, and so I thought I should use a different name than Edwin, and that became Ido. So there you go.
okay, very interesting. All right. We were asking about the issue. The reason I brought this up was because Vladimir is talking about or thinking about writing a book to put together as material. Okay. And the question came up was, that's a lot of work to write a book, a big, thick book. Vladimir is faced with the same issue that Ido mentioned earlier, which is nobody's really paying attention to his model, if you will. How to get some attention for his model? Is it apathy or resistance, or what is when you're a dissident and you have a model that conflicts with the mainstream established dogma? How do you get your ideas out there? How do you it seems that writing papers in scientific journals is kind of a major roadblock. You can put them on online science sites. It's not really clear to me that you get a lot of attention if you do that.
Well,
And I do concede that Vladimir has gone to extraordinary lengths to explain to all of us his theories. I mean, by giving 8 consecutive talks in the summertime and that sort of thing. And I know we're asking him contradictory things. On the one hand, we're asking him to describe in very general, non-technical terms, a quite brief way. And then on the other hand, I'm saying, well, I want the theoretical basis quantified.
Yes.
So he's done a lot, but we're asking him for a little more. Yeah.
Let me tell you a few words, guys, because what I've done for 24 years of my work on this model. Let me remind you, Durant, my father, scientific father. You know why? Because in 1937, he told very important point that new physics will come through the cosmology. So cosmology. Cosmology, it's not only branch of classical physics, it's a base for a new classical physics. It is exactly what I've done in my 24 years experience. I will tell you why. Everybody knows that there is so-named conservation laws, conservation of energy. But it is not absolutely true. Why? Because in my model, it's true only for the closed system, physical system. If you have no input, you have nothing around, you put your boundary and you told inside of this volume, there is a law of conservation energy. Yes, there is. But if all the time you have additional energy to our world, you cannot even tell there is saving energy. Why? Because we have extra energy coming to our world. The same, oh my goodness, my connection is unstable. Guys, I will continue. If it will be some problems, I will restart my computer. Sometimes it's happening. The second very important point, we are doing with you, we think that the entropy of our world is going up because house and all this stuff. And at the same time, we have new galaxies, new stars coming all the time. Even in our galaxy, at least one new star every year. where it came from, where this energy. What about this? Even house. There is no house. There is an order in our world. What I mean, Dirac was absolutely right. New physics, new classical physics. We have our basic 19th century, 1905. It was killing our classical physics. And all the mathematics right now we have for 120 years, it's a bullshit. It's no correlation with physical laws. One of the points, we're talking about microwave background radiation. We have temperature. We measured it with accuracy, 5 digits and so on. And nobody calculated even. Nobody has any clue what is this temperature about. It
Vlad,
was 2013 when I calculated that temperature with accuracy 5 digits, 5
Vlad,
decimal digits.
Vlad, if you're having connection
We have
issues,
our step. I'm
turn
so
your
sorry.
sorry, if you have connection issues, turn your camera off. We'll be able to hear you better.
Okay, I don't know. I can do it, of
I
course,
can hear
but
you perfectly.
Yeah, he's breaking up every once in a while, that's all.
Yes, he
you know,
is.
you can continue your talk. I can restart my computer because I
No,
don't
no,
want to lose you.
all you
For
have to do
me,
is turn off your video, and
okay, let me try.
your voice should be a little better.
You
I
you
hear
think
him
so?
perfectly.
Yeah,
Okay, guys. No, I don't know what to do because I do like to see you and I want you to see me, guys. No, it's not good. By the
It's
way,
not too
Ido,
bad.
please show your picture because I do like faces. I do like your smart eyes, to see them and to see. Do you understand me or not, guys? No. We have our group of people. We connected already for 1 year at least. And you're my friends right now. That's why I ask even Harry, guys, let's talk about what is wrong with myself because I've done so much and I don't know how to present it. That's why I'm thinking about to start writing the book because it should
Yes.
be one picture. And it takes at least one book, at least. Why? I will tell you why. Because I published 40 papers. I uploaded on different sites more than 100 papers. How I can tell you if it was about 100 papers with you guys? How to do it? I'm confused all the time. I try to be as simple as possible to show you my understanding, my ideas. Because to talk about the details, it's one story, it's book. But to talk about the idea, the most important part in classical physics, there are no new ideas in our contemporary physics. Orthodoxies, they're following their religion, and that's it. Magical tricks, all this stuff. It was a very good presentation of Harris today. He told all the truth about the situation with our physics, all of it. I have an insult like with the latest Nobel Prize in Physics. What is this Nobel Prize in Physics? Artificial intelligence. Physics? I cannot believe it. It's insulting for me, guys. We have nothing in physics to present to Nobel Prize committee. I was totally frustrated. I was pissed off with this new physical advantage, achievement of our physics. What are we talking about, guys? We are in crisis, and no doubts about it. And nobody talking about the crisis and proposing something real. And I'm working on it 24 years. I'm trying to talk to people. By the way, I have some statistics of my papers. You know how many people during these years saw my papers? 100,000 of them. 100,000 of people, they have an interest in my paper, in my model. But what is the result? Nothing. I tried twice to put my papers on archive. They didn't take it. Forget about it. The second very important point, I tried to
I'm
put
sorry. What was it that you said you tried to put your papers on what?
on archive.
Oh,
There is
archive.
a archive. Some huge a huge site, let me tell you, bibliothèque like this
Yeah,
one.
you need to have apparently you need to have some kind of a sponsor or something for that.
So can I
I'm sorry.
respond to that, Vladimir, what you just said there?
Go ahead. He's having the
Yeah.
same issues that you are.
Well,
That all of
yes,
us.
that's why I would like to respond there, because I do resonate with everything that you say, right? Well, no matter what you do, no matter how much you distill your work, it doesn't seem to matter, right? It's not that's why I concluded it's not our game, it's their game. If you're not part of the game, no matter what you bring to the table, it doesn't matter how good, especially if it's good, the better it is, the more you will be shunned, the more you will be attacked, seems to be the case. But also on the more practical side, so I was aware of that quite a long time ago, if you will, through interaction with other people. So we never focused on the scientific community, anything that you could consider, the professional community, because I found out early it's a no-go. They don't want to listen to you. So what did I do? I tried to find another way. My own way to get some notoriety in the world, if you will, is to go to conferences like the Electric Universe or from the ISCMNS, so the cold fusion community. And in both those avenues, I've been able to, and luckily, thankfully, been able to do 3, 4, 5 presentations in total. And they get watched in these days by people. I mean, the way I do research, the way I get my information, the way I entertain myself, and the way I get news is all done via video nowadays. I mean, look at what we're doing. Okay, I'm not participating with video, apologies, but look at what we're doing. So my answer
It's
to
very
this,
important to have your opinion about it. Unfortunately, it is the same opinion as myself. But let me continue my talk, and you will see
yeah.
what
So
I've done.
one last thing, then I'll let you continue, sir. I'm curious, but what I did is do videos, do presentations. I'm connected to Gareth Samuel, who did video presentations on my model. So I wrote a book. So just explore all the other avenues and simply ignore the mainstream. At least that's been my avenue so far, and somewhat successful, I would argue. So that's all.
Have you approached Demystifying Science channel on YouTube?
There's a podcast of me with them way back when, almost 3 years ago now.
Oh, so you have a podcast on
Yep.
Demystifying Science. Okay.
Yes, it wasn't the best in my mind, but it is there. Yes, sir. So that is one of the examples that you just brought up, the way I try to get some notoriety and cause some change in the world. It's just what I've chosen to do. And like I said,
Okay, let me continue because I've done practically the same what you told right now about your story. Let me tell you one more time. I will repeat the same point. I've done at least 20 different, speeches on a different meetings of our group. And with you, I've done 9 of them. It was 8 in a row, and then it was the last one 9. But then I understood there is no meaning because there is no response with your Zoom sessions at all. The same story with our hairy groups, at least 9, 10 I've done it already. And what is the response? I don't have response even from you guys. This is my point. All the time I'm sending to you my papers, and what is the response? Nothing. Only Harry and Nick, they read my papers. So that's it. Simple like this, guys. What is your opinion?
I think Ido is talking about expanding out of this group into other groups and giving them talks as well.
Okay, let me continue because guys, I have to continue one more time.
Let me stop you here, Vladimir. Let me ask Ido a question. There's a number of these other YouTube science channels. Have you dealt with any of them? Have you approached them other than Demystifying Science?
Let me think now. Demystify came to me.
See the pattern. See the pattern. Gareth Samuel.
Gareth Samuel. I'm strongly connected to Gareth Samuel a long time, basically since he began. We early on connected. He likes the model that I have, and I like what he does very much. So I'm very critical of who I interact with in that sense because, well, I always try things, not to be shy or anything. I try things very much, but if I notice that, it's not going to be helpful in any way or it's not taken very seriously or whatever, then I'm quickly gone
Okay.
because it's no use.
The point I'm really trying to get at is I'm trying to find out what channels that Vladimir might be able to approach.
Demystify Psi is, if he has not been on Demystify Psi, that would be an excellent opportunity because they do dive in all kinds of topics, and I'm willing to bet that they will be able to ask good questions as well, but they need some preparation time. So somebody needs to introduce him there, and he will be interviewed. And that is exactly what I meant. I think Rick responded there. All the presentations here are, I mean, that's really good, but it's not going to help you in the notoriety in the world. Demystify Psi will maybe give you a few thousand views at the very least. So maybe people start talking about your work. That is my philosophy. If you have something to say, you need to talk. That's what you're doing. But in order to be heard, you need to be heard by the right people that have that big horn. And that
You have
big
to
horn is the
expand out.
Demystify Psi, for example.
Yeah, you have to expand out from this group
Yes,
into other
yes.
groups.
Okay. Any other channels? You mentioned See the Pattern.
See the Pattern, Gareth Samuel. And
I think you should start there I think you should start there and do that. And you have probably more than enough material and you can probably talk very loosely all about it. So try and get on there. And I'm pretty sure they'll have you if you have a new cosmological model that may be competing. And I know nothing yet. I do apologize. I'm totally new here. I'll look into it. But if you have a story to tell, and I have the strong impression that you do, go to Demystify Psi. Actually, that would be my way to be introduced to your work, right? That's how it goes.
You're based in the Netherlands, are you at present?
Yeah.
Yeah, in Europe. Okay, like me, I'm in Ireland. But when I first got involved, I got involved in another group run by the late Glenn Baxter in the USA. And he said to me, "Oh, I can see that the dissident community is much more organized in Europe than the United States." I said, in my view, it's the other way around. It's very, very weak in Europe, and actually it's stronger in the United States. So that's been my experience over the last number of years. There are more avenues, certainly in North America, than in Europe, contrary to what might be thought.
Well, you touch on a very interesting cultural difference. Europe is much more academic and established, so much more protocol. And the disciplines that are there are also more of that same kind. So they are organized, high stature, protocol, established. In the States, it's a little bit odd. Somebody that is a complete nobody, like myself, came there in 2015 for the first time, and I simply attended an Electric Universe conference. That's when my snowball started rolling. That's when I connected to people. And then I got a tryout in a breakout room to present, which was successful. The next year, I got a spot on the main stage to do a full presentation. That went successful. And then, the snowball became bigger. In America, you can be a nobody and grow from nobody to somebody. In Europe, that's not allowed at all.
The only exception I might note is that during my initial years getting involved, I did attend a meeting in St. Petersburg in Russia on space-time gravitation. And I found one of the most open meetings, perhaps paradoxically. I met a lot of people. I haven't unfortunately kept in touch with them, but they have had more conferences of the same nature, space-time and gravitation. But so that was Europe. So that was an exception to what I've said.
Hey, Vladimir, do you want to continue on?
Yes, I want to continue my way because everybody has his own way. I have my way. Let me continue my way. Guys, what about archive? You asked me that somebody should present my paper for archive. I published 40 papers in a journal of high energy physics, gravitation, and chairman. Our main guy is professor, very well-known professor in physics, in cosmology, in so on and so on, Christian Corden. He presented my paper published in his journal to archive. Nonetheless, who cares? It's not valid, and that's it. Simple like this. You know, well-known physicist published my papers in his journal. He presented my paper, and it was not enough. What I'm talking about, archive. The second very important point, I've done, guys, 2 presentations, one in Italy, one in America, on some conferences. No result. You know, people, they're coming to these meetings only to present, but not to listen to anybody. Right. This is the main point. There is no any feedback. What I've done in my life, guys, you missed maybe 100,000 my process I have right now on my papers. I took at least 10,000 different emails addressed for physicists who publish papers in astronomy, cosmology, and so on and so on. And then on a regular basis, I sent my papers to them. More than 10,000 qualified people. I found them from publication, not from your meetings, from all your stories about additional report. I've done already more than 20 reports with you guys. And I have interest in my papers. 100,000 people, they saw them. They read my papers. And no one well-known scientist responded me. I sent my letters to Nobel Prize laureates, to all the professors, all universities. No response. They had blocked all the information about my, letters, about my the references, and so on and so on. It seems to me to present my papers, I've done maximum what I could do. I've done, my reports, my papers to 10,000 people. That's why I have 100,000, views and reading of my papers. It's not from the sky. It's a hard job it was, to find all of them and to send on a regular basis to all of them. I've done it, and response, nothing. Nothing. That's why I'm trying right now to start writing the book. Why? For maybe future generations, maybe from somebody else in 20 years, 100 years, who knows? Because
Vladimir,
during my 24 years, I found so many genius classical physicists. I opened for myself the history of classical physics, 300 years, 200 years, 100 years. So genius people, you know why? Because they propose great ideas based on nothing from their brains only. And I am not genius. I'm a regular guy who knows much more than all of them 300, 200, 100 years ago. And I'm trying to explain, to answer the questions from physicists, from astronomy, from experimental results. By the way, by qualification, I'm experimentalist. I'm not theoretician. That's why I do like mathematics to explain my experiments in physics. That's this simple like this. By qualification, I am a lazy physicist. I defended my PhD, Doctor of Science, and so on and so on. There's more than 200 papers in the. That's why I have my qualification in a different field, even lazy physics. I was in a best school in Moscow for many years. I'm so happy. I passed all of this. And I started my cosmology in America 24 years ago to think about what does it mean? What does it mean, photons? I couldn't answer myself at that time question.
Can I
If
ask you a
photon
question,
is a
Vladimir?
wave or it's a particle, and so on and so on. That's why,
Vladimir,
I have my story. I'm sorry?
Vladimir, got a
Yes.
question for you.
Yes.
If I may, sir. What is it that you're trying to achieve? And I don't mean your work, your model, your views, but what is it you're trying to achieve by publishing the papers, and where do you expect some change to happen? And is that even a realistic view? Because that touches in on the questions that I think was Ian Cohen, I see your name now, very good, asked me. To my mind, the scientific establishment is simply like just to pick one, the Catholic Church, if you will, the Vatican. If I go to the Vatican and tell them, well, your scriptures can tell this and that, but I found out that God actually meant to say that and that, and especially if I'm right, the more right I am, the more I will be pursued and crucified. They don't want to hear it. It's their story. It's their church. Right, so that is what's happening, and I think that is a problem that we all run into, and I really feel for you because this is common. Science doesn't do what it's supposed to do, but what is this? What is it that you are trying to reach, sir, with your papers? Are you trying to reach as many people as possible? Are you trying to reach people at MIT or NASA to acknowledge your work? What is it you're trying to achieve?
So much for good question, Tessa, because what you talked about your story, I have the same story. That's why any dissident, anybody propose something different from the religion we have right now, have the same story. That's why, thank you so much for your comments, for your story. It's the same. You asked me a very good question. What I'm expecting from physicists, from classical physicists, recognition of my model. Recognition. What does it mean? Take basis, because always I'm talking about model. I cannot build a new classical physics by myself alone. Forget it. All my papers I finished. It's a model only. It's a basis for a new classical physics. Please recognize it and start working, new working. Many times, guys, to you, to our group, I told guys, if you are interested in this, maybe you want to develop some new ideas, to continue my ideas, to do something yourself. If you will go, I will be more than happy. You see, I'm stuck. Why? I put only basis for a new classical physics. And to talk about the whole classic physics, you must have all the physical community working on it.
That may be your problem.
And that's well, that is indeed, and not trying to steal the thunder of anybody here, but if I can respond there again, Vladimir, I think, and this is just, from my perspective, in all humility and respectful, I think you've done excellent work so far. What you're telling me, no criticism there, really good, but you need to expand, because you are not going to get the recognition from the mainstream. That's at least what I suppose as to be truthful, but you are going to get that recognition from all the dissident groups that are growing all over the world, because I've been traveling now a little bit, and there's a lot of dissidents. There are so many people that are so ready for new physics, but the mainstream, that means MIT, NASA et al., they don't want it, and we feel it. What I'm saying is the recognition is where you're going to get it with your peers. That's here and in other groups. And you can expand to those new peer groups that are receptible to your ideas, are people like a Demystify Psi. They interview researchers and etc. like yourself. Every week they have another one. I've been there too. Gareth Samuels, I think he's been there. There's many people have been there. Many dissidents have been there, and they are able to at least ask some sensible questions, debatable. But I would argue, sir, please go there, find your recognition there. I think you'll be much, much happier. And that's where change is going to come from anyhow. Change is not going to come from mainstream anyhow. I'll shut up.
Okay, looks like we lost Vladimir.
Maybe he's doing a reboot.
All right. Let's see. We got. I just got the warning here. We got probably. Let's see here. 8 minutes. All right. See, we did. Vladimir is gone. All right. Any other comments? Seems like I've hit a nerve a little bit.
I did not. Did I scare him off there? That was not my intent.
He disappeared. I think his computer.
Oh, okay. Phew.
I'm happy that Ido has come to join us today, and I do look forward to hearing his presentation either here on a Sunday or in the Saturday sessions hosted by Ian, Dr. Cohen.
Um,
Oh my.
Ito, why don't you give them the address for the structured atomic model? I did it before, but I don't know if people have looked at it yet.
Can I type that in here? Let me put
Yeah,
my
down at the
glasses.
bottom, down at the chat, click there and you can type it in. It's etherealmatters.com or .org, right?
No, that's an old one.
Oh, okay.
Let me type it.
While that's being typed in, I might mention that I look at YouTube feed here mainly to find some interesting movies that are free on YouTube. But in terms of the science content that pops up in my feed, it seems like virtually everybody is talking about the crisis in physics, in cosmology, and so that it seems like the main flow or momentum of current in all of these videos is promoting questioning of mainstream views.
Well, like I said, they've been spending 50 years trying to solve the unification of quantum mechanics and general relativity without much success. And I think they've really recognized now that it's not working.
Yeah, Harry, you mentioned that general relativity was based upon special relativity or came from special relativity. I don't understand. It seemed like general relativity is an entirely separate thing from special relativity. I'm just missing something, I suppose.
Well,
I think
go ahead.
GR came first and then SR came second, no?
No, you got it backwards.
Okay.
The idea is that SR is a special case of general relativity, and then what they're saying is that in a small region of space, general relativity reduces to special relativity.
So that's sort of the TikTok version of it.
With computer.
Huh? What was that, Jim?
That's sort of the TikTok version of the relationship between these two theories.
Vlad's back.
I'm agreeing with you.
I'm back because I had my problem with unstable connection. I'll fix it. Sorry. I want to continue and I want to answer a very good question I was asked. Let me tell you, dissidents, you know my experience, at least for 10 more years. Dissidents, they're good, but they're very conservative because they have their own ideas and they don't want to listen to anybody else. Not standard physics. Forget it, guys. You cannot join, you cannot combine all these disciplines because so many of us, so many different cosmology models, forget about it. And my intention right now, I told you recognition, but not by well-known physicists, dissidents, forget it. I want to write, and I told you, for future generations means for students, for young people, they will not contaminate it with all these bullshits in physics right now. And they will start from the beginning. They will come back because of me, thanks to me, to 19th centuries, to the beginning of 20th century, and to forget about all what done, like mathematicians. Now, they are not physicists. They're trying to trick only. Even when they subtract one infinity from another one, and they have a physical number with 8 digits after the comma. Can you believe it? How much tricks you must have to subtract. So renormalization, maybe you know this procedure. You know, to achieve some result, Let's subtract one by one, and we will get. You know why?
How about
Dirac.
dividing by 0 for black hole?
Oh, they can do it too. Believe me, they can do it. You know why Dirac? He told that he spent his right life. He is unlucky. He is a failure of his life. He is Nobel Prize laureate in physics. He tried to fix all the problems with quantum electrodynamics, with these infinities and so on, and he didn't succeed. Why in 1937 he proposed new cosmology and new classical physics? Because he was totally frustrated with quantum physics, with everything what it was in his time. It's only 100 years ago. He was frustrated. Guy who developed this quantum electrodynamics, and he told me, I'm a failure of this life. I didn't succeed. I didn't do my job. And you know what happened to him after 1937? He was named crazy, guys, crazy. You know, he's unique. He's, forecast that future of classical physics will come through cosmology. And nevertheless, he was crazy. Guys, I'm not crazy. I'm a real guy, guys. I don't want to be crazy. That's why I'm not trying to do anything, not with dissidents, not with a famous physicist. It will be maybe good luck to somebody from them, Penrose. I like Penrose. He blamed this quantum physics. He told it's absolutely wrong. Maybe at last he will see my paper, because all the time I'm sending my papers to him too. Unfortunately, I don't have any response from him. And he will, oh, what
Well,
the
The
minute
problem
talking
may
about?
be,
Okay.
the problem may be that there's a theme where it appears you are finding fault with others. And
It's not fighting against you. No, wrong. Jim,
all right.
I'm not
We're
fighting.
coming up to the end. We're coming up to the end. We got about a minute here. Okay, less than a minute. Thank you, Vladimir.
Guys, if you have any proposals, any comments, please send. You have my email address. I will appreciate your income, because I want to do something for the future, guys, not for you. You don't accept it, because all of you, including Jim, he has his idea. Forget about everything else, And the same story with all of us. I'm not talking that he is unique. No, he's standard dissident. You're dissident too. You're following your idea. All of us.
What you need to do is start praising others rather than finding fault with them.
All right.
I am not fighting
write
against you, Jim. No, you're absolutely wrong. Many times I will tell you the same.
All right. Okay.
When you write to other physicists, ask them questions about their work.
Okay. All right. We're going to begin the end here. I want to thank everybody for participating today. And Ido, I appreciate your coming by and seeing what we have